Okay guys, we're back here. We are doing the 6 simple machines. In our last lesson we learned about the inclined plane, the lever, and the pulley. Today we're going to be focusing on the screw, the wedge, and the wheel and axle. Okay, this is a rather short little video here, or PowerPoint here, to get you through those 3 machines. Once you're done with those 3 machines, you should be able to finish your worksheet and get that submitted to me today. So let's get going, and the first of those that we're going to talk about is a screw. So what is a screw? A screw is a specialized inclined plane. It's an inclined plane that's been wound around a central cylinder. Here you can see some different examples that we have. We have an actual screw, we have a jar lid, we have a drill bit. Okay, so those are examples of different types of screws or inclined planes around a central cylinder. What does a screw do? It takes and converts rotational motion, or the motion of turning, into linear motion or straight line motion. It does this by converting torque. If you don't know what torque is, that's just simply rotational force, into a straight line or linear force. So you turn the screw and it goes straight down into whatever you're screwing it into. If you're using a drill bit, you push the drill bit in a straight line, it spins or torques. We have rotational motion that allows the drill bit to go in a straight line. So again, we're just simply converting rotational motion to linear motion. So how do we do the mechanical advantage of a screw? This is a little different than what we have been doing before. So this has its own little mechanical advantage. Again, if you have the force in and force out, you can calculate the mechanical advantage. But for the ideal mechanical advantage, what we do is we divide the circumference by the distance between the threads. The distance between the threads is commonly called the pitch of the screw or the drill bit. Okay, so again, we just take the we take the circumference and divide by the pitch. Okay, again, all of you should know what circumference is. That is the distance around the object. Okay, for your screw, you're going to measure the circumference of the top of the screw. Doing the drill bit, the top of the drill bit, the top of the lid, whatever it is that you are screwing on. Okay, so pretty simple, straightforward. And now we are going to move on with what is a wedge. You can see here in the picture some different wedges. We have an axe, we have some knives, we also have a zipper. Most people don't realize that a zipper is a special type of simple machine called a wedge. So, what are wedges? Wedges are nothing more than 2 inclined planes that have been joined back to back. So again, just like the screw, the wedge is a special type of inclined plane. Why do we have wedges? Obviously, with the axe or knife, we're using those things to split or cut. It makes it easier to do. They are also very good about holding things in place. For example, a doorstop is a special type of wedge usually. So, how do we calculate the mechanical advantage of a wedge? You see the picture there. The wedge, we have a letter S. Representing the incline, and then we have T representing the height of the wedge. So how do we calculate the mechanical advantage? We simply divide the length of the slope, that is the length of the ramp, that's letter S, by the thickness of the big N. In other words, the height of the wedge. So we're going to take S and divide by T. Okay, if you remember when we did an inclined plane, it was the same thing, except you only had half a wedge. You had a single inclined plane, but it was still length times height. So S divided by T. Now, as with the inclined plane, the mechanical advantage gained by using a wedge requires a corresponding increase in distance. So it makes your work easier by decreasing the force that you're going to need, but it does require you to apply that force over a longer distance. Okay, that is our wedge. And finally, we have what is called a wheel and axle. So the axle is stuck rigidly, okay, to a large wheel. You can see here in the picture that is a ceiling fan. You can see the axle in the middle, and the wheel spins or revolves around that. Okay, this is accomplished by causing the axle to spin. Okay, so both the axle and the wheel are spinning. Don't forget about that. Now, how do we calculate the wheel and the axle? We simply take the radius of the wheel. Again, the radius is from the center of our circle to the very outside. Okay, so we go from the center to the very outside of the wheel. In this case, that happens to be 5. And we divide that by the radius of the axle. So now we're looking at just the inner circle, the navy blue circle, and it goes out to the edge of that, and that in this case is just 1. And what we do is find the ratio. Now, what is a ratio? Ratio simply means that you are going to divide. So in this case, 5 divided by 1. This particular wheel and axle has a mechanical advantage of 5. So what does that really mean? The wheel and axle can increase speed, so we can speed things up by applying the input force to the axle. This is the way a wheel and axle on a car works. This combination would increase the speed 5 times. Okay, so by applying the force to the axle, okay, again, applying the force to the axle, we can multiply the speed or the force on the wheel 5 times. Okay, the wheel is going to go a greater distance, 5 times the distance, so therefore we are increasing the speed. We only have to move the axle a short distance, we can move the wheel a long distance. Okay, so those are your 3 final simple machines. Go back, finish up the worksheet, get those submitted, and then that will leave us with 2 more lessons. We're going to be sticking with simple machines, and in these last 2 lessons, what we are going to be doing are gizmos. The first gizmo will be you using a pulley and seeing how a pulley works and how the mechanical advantage is calculated, and about how using the different types pulley systems, whether it's a fixed, movable, or a combination, and see how those work to make work easier. And then we will also do a gizmo with the 3 different types of levers, first, second, and third class. Okay, finish up your worksheet, get that submitted to me. Again, this worksheet that you're finishing up is a 25-point assignment. It was rather long, so I believe it is worth the points. Okay, so do a good job, and I'll be seeing you in the next lesson.